Hello, everyone. We are here in InfoComm 2024, and we have Andy Robinson from 7thSense. It is great. Obviously, we have been creating a partnership lately, and we are really looking forward about what 7thSense is doing now. Thank you, Andy.
Thank you very much, Cesar. Thanks for having us attend the presentation here. So we, when we embarked on this, we wanted to talk a little bit about how we work with media for displays that aren't just a regular old 16 by 9. So at 7thSense, we have our Delta Media Server product, and it has, for the last 20 years, we've been doing all sorts of different displays, but the one thing that's been very constant for us is that we've always worked with uncompressed media. When you are working with uncompressed media, of course, it's a very heavy workload. You have large format displays demand a very high resolution. You get 8-bit, 10-bit, 12-bit files, high frame rate. And so with all of that, it does kind of present some challenges when you have, in an LED sense, perhaps you may have displays that are scattered all over the place. And so one of the things that we've always wanted to try to work with the customers is try to understand good ways to optimize that workflow and make sure that we have content arranged and optimized and do pixel packing before handing it off to maybe an LED processor to send that to the actual displays.
Yeah, this is very interesting because obviously you guys have been doing some of the top jobs all around the world for these differently shaped displays, right? I mean, there is many very big examples, but the fact is that the standards, the way GPUs work, the way LED processors work, all this is expected to be in a 16 by 9 ratio in any of these standards. And not only for SDI, but even HDMI has some limitations in how far you can go with these things. And you guys really faced a lot of, challenges trying to achieve that.
Yeah, it's interesting. There's you have kind of maybe, I don't know, competing, but different flavors, right? If you're working in an EDID format, then you might work with some custom resolutions, and I see your IPMX pin. So, if you're looking at 2110 and using custom resolutions using IPMX, then you have some flexibility there. But a lot of times, if you're dealing with SDI, you're pretty locked down. You get a nice, that's going to work because it's a standard. It's nice and clean. But then you're limited to, it's got to fit within this shape of a rectangle, right? And that's where we look at using our composition mode, or we look at using different methods to pack the content into that raster. So when we are talking in terms of doing something like a warp and blend type of setup, what we'll use there is sometimes we'll use UV mapping if it's a nice complex projection, or if it's even for a pretty standard projection, but it's maybe multiple projectors, or it's really ultra wide aspect ratio, or very tall type of aspect ratio. Then you would want to use maybe a warp and blend to try to pack those pixels into the appropriate space, get them all blended nicely together. In Delta, we have manual warp and blend. You can also use ST mapping to rearrange the content as you need to, or then also adding in camera-based calibration to make sure that you have all of the right pixels in the right place for the projection.
And as technology evolves, I mean, there is now LEDs with different shapes, and you have triangles, you have curves, and all these things. How do you apply these type of tools for other setups that are not projection? Because in projection, it's quite common to see it, but obviously you guys have been doing a lot of LED as well. So
yeah. So that's where we talk a little bit about it a little later on, but one of the things that we have done through the recent project, the Sphere, we've added in the ability for us to do ST mapping into the content. So when you have, a regular raster, and then you want to actually make that go around a curve, then the LED manufacturer may present to, the display chain a certain LED mapping that has to match that signal so that all the pixels end up in the right location. What that means for us on the media server side is that we need content that's either been pre-mapped for that specific mapping. If you're familiar with UV mapping, then you'd use something along those terms.
just to clarify, UV mapping is when you open up a map so it looks in a flat surface, something that is not
Ex-
flat.
Exactly. Yes. Thanks. But then, if you wanted to, let's say that you don't have a model necessarily, but you need that content, or you don't have pre-mapped content, then we have an ST map that would essentially tell that unmapped content where it needs to end up on the output, so that the LED processor receives that and knows that I want to send that pixel to that LED and that pixel to that LED.
Yeah, because in many of these shapes, I guess that pixels are not even at the same distance, right? There is quite a bit of warping in the how the lines are working in there.
Yeah, you could have, sometimes it's maybe just pinching a little bit together. And so it's, you look at the frame and it makes sense. Sometimes it could be completely scrambled. And it's just a matter of how the LED manufacturer, how the LED processor has been configured to receive those pixels. And then we want to make sure that our ST map knows when we pass a standard rectilinear image into that ST map, we're going to rearrange the pixels to suit and go onto the appropriate location on the display.
Okay, that's awesome.
Let's see. So when we are talking, UV mapping, as we were saying, that's when we take that full model and we unwrap that out and lay it all out. So it's a nice analog when you think of in terms of a UV map to how we would do that sort of application with with an LED surface. We also do eye point mapping, or we can apply mapping modes in a virtual environment and then apply that into the LED surface as well. So different methods for us to create those ST maps dynamically would allow us to create a map if the source content that we want to put on this funky display, if that source content is fisheye content, then we might create an ST map that matches the LED mapping, but is expecting fisheye content. Or if we wanted to do a spherical map, or if we want to do it, like a lat long 360 kind of a map, then we would create that ST map so that, again, we get those pixels from source content that could be applied, as a fisheye, could go anywhere to any fisheye projector or whatever. But now we're going to actually play it back on this LED, this curved LED screen.
Oh, that's awesome.
There's another technology that we have in Delta Media Server, and also in our new Actor Media Server, but it's our composition mode capabilities. With a composition mode, I kind of like to think of it as a reverse LED processor. In an LED processor, we're going to pass in a raster and say this section of content at this coordinate and this size is going to go to this LED, and this section of content is going to go here. With composition mode, we kind of work that backward, and it's all about optimizing the workflow for the content delivery. So again, we're working in uncompressed. The files range in, maybe 8 megabytes per frame to, I don't know, several dozen gigabytes per frame, right? Depending on what the resolution and bit depth and so forth is. When we are thinking in terms of how we're going to optimize the system, we're always looking at, look, we don't want to oversell our customer something that's just going to have a bunch of wasted pixel space. We want to make sure that that is consolidated. We pixel packed it as tightly as we can, and then we use our composition mode to break that out and send that over to the actual display. So we work with the customer to go through the design process to help them figure out how they're going to build their content for our actual application. This is an example of the Thomson Reuters building. We did this years ago, where they had the design process was about 80% or so of wasted pixel space if you're actually designing that element. And then we worked with them to optimize it down into a much smaller frame. They render out that small frame. We load that onto the server, and then we go through and using composition mode, we cut that frame up into 4 different outputs to send to the LED processor. And then the LED processor says, okay, I know the coordinates. I want to take this section of pixels and I put it on that display and so forth. So that's the way that we've used composition mode for a fixed display, but we've also used them to animate displays. So if you have an LED wall that's moving apart and coming together and changing heights and shapes and widths, whatever, then we're able to, through a number of different communication methods, we can receive that data in and then use our composition mode to say, okay, it kind of gives you a viewport into the content. We're going to move this section over here, and you're going to see that other section of content as the show is moving, as that LED section is moving.
Absolutely. Yes, and this can give, I mean, for live events and things like this, it brings very creative ways of working. And that can look quite impressive. And if you are controlling the content correctly, it can actually give a next level of experience, right?
Yeah, absolutely. So we've done, LED moving set pieces and that sort of thing, which are, maybe not a backplate type of scene, but just, ribbon LEDs on steps and that kind of thing. Moving that image around, you can bring it together, you can move it around, and the experience for the guest is to see what the eventual impact is of those moving sections, and it all kind of makes sense for the guest. They don't see seams and that sort of thing.
Yeah, that's absolutely great.
So over the last several years, we've been working on our next range of products. With that, we've brought in, really through Sphere, through that project, we've had a number of advancements in our development. We've introduced our Actor Media Server product, which is a next generation media server. It's much more optimized on a modern code base. From Delta. Delta still exists, absolutely, but this is going to move us into new technologies. We've also introduced our Juggler Pixel processor, which is an opportunity for to kind of stand between the media server and the LED processor. And that gives us the ability to composite multiple different sources. We can bring cameras, we can bring media servers, we can bring generative engines into the Juggler, do compositing inside of the Juggler, and then send that off to the LED processor. And then we've also introduced our Conjurer product, which is our generative engine. And that's another, the Conjurer product can all work with the Actor and the Juggler to launch, the Conjurer launches on real projects or not standalone, that kind of thing.
It's like a control of different systems.
So while the Conjurer, the Actor, and Juggler are all controlled by Compare, which is the software that kind of sits over top of all three products. And with that, you get pre-visualization capabilities, all of your timeline programming, external control, very robust API for external control and monitoring of the system, and gives the user the ability to kind of see what's happening as they're building the show or offline, doing offline programming, and then loading that show onto the system when they get off the plane.
Yes, absolutely. I mean, it's very interesting because something that I wanted to mention, and clearly the juggler is fixing that for baseband video, but this is one of the things that as well systems like 2110 that I know that is something that you guys have been passionate about helps with optimization of how you send the video and how many streams can you send to the same source and being able to control it, right?
Yeah, absolutely. So the our first generation Juggler product was all baseband based, DisplayPort, HDMI, SDI. Juggler 2 that we've now launched, that is 2110 currently. So as a first port of call, we wanted to make sure that we had the 2110 story
Absolutely.
right there. With DisplayPort coming online in the next couple of months, and then HDMI to follow suit. And being able to, having Actor and Conjurer also supporting 2110 as a natively, that allows us to bring all those different streams in, and again, cameras and other systems, bring those streams into the Juggler and handle that sort of compositing, doing positioning of windowing type of capabilities, or doing the ST mapping directly within the Juggler as well to take those sources and put them up on the mapped LED.
So you can take several streams, 10 gigabits, put them together and put them as a bigger one composited image.
Yeah, the Jugglers can be scaled together. So we have a fiber bus that we can allow to kind of scale that canvas up to from a single 4K up to a mega canvas size of a 16K by 16K. And the ST mapping that I was mentioning before, we have a workflow there. So if you have, however you get that content into the 2110 network, if you can get that content in there, then we can receive that stream, apply that ST mapping, and if it's a fisheye camera that's plug, a 2110, based fisheye camera and you want to put that onto the network, we bring that into the juggler system. We apply the ST mapping, and then you have your fisheye image that goes out to the LED screen, and it matches the mapping of the LED.
Okay, that's great.
Now, one of the other things that we did introduce with the performer range, we've recognized, we've had customers that come to us and they appreciate the uncompressed nature of the content, but the challenges that do come across with the workflow. We're talking about really big files, a lot of storage, a lot of bandwidth, and the management of a multi-node system where you have maybe multiple servers that are rendering content, and they're all doing different parts of the same display. There's always a little bit of a challenge there. And one of the things that we did to help with, again, handling that media for these types of displays is we introduced a new tool set with the Compare software called Asset Management. And what Asset Management does, it gives us metadata to tell each piece of content, I belong to the whole movie clip, and I'm supposed to be played back by this server or that server or that server or this generative engine that should be playing me, or maybe it's the ST map. And
Is that 7thSense proprietary metadata?
yes, yep. So this is a part of the Compare software. It's one of the features of the Compare software. But that metadata it's proprietary. It's a JSON file, so anybody can open it and look at it.
Yeah.
But we interpret that JSON data to know when we stick it in the database, we ingest that content. We're going to take that data, and if this server is supposed to be, and this could be either a multi-render LED screen, or it could also be maybe a scene-based experience at a museum or a theme park. If we say that this piece of content is supposed to be played back by server A to do exhibit XYZ, then it knows when we ingest that content, it can automatically be copied over to that server, and it's ready to go,
Okay.
within a few minutes.
So it is for communication internally between the different 7thSense machines and okay, that's awesome.
Yeah. So we use the metadata to help with the distribution of content and making sure that we have the right content in the right place. We also made it endpoint aware. So this can be a one-to-many type of sync, or it can be a many-to-many type of sync. So if we have our database bringing in content from a control PC that user 1 is using, user 2 and Compare, it's multi-user and multi-platform. So if you got a Windows user and a Mac user and they're both working on the same system in our software, and both of those users can bring content in from their machine, or we also have NAS support. So you can ingest the content directly to the NAS. The content team can render directly to the NAS, and when that content is then ingested into the database, it is automatically distributed to the correct endpoints for playback. Another option when you get into much larger sizes, then we also start to talk about NAS streaming. So being able to do real-time streaming off of a NAS, at very high bandwidths, multiple streams simultaneously. Yeah.
Okay, that's awesome.
Oh, I should have clicked on that one. So this, we can talk a little bit about this, but not a whole lot.
Yes.
So at Sphere, this is a shot from Postcard from Earth. And this is using that same tool set to handle all the distribution, all the ST mapping, all of the kind of workflow optimizations that we were able to introduce to make programming this very large screen much simpler experience.
I mean, and I guess that this is the most interesting part of this project. It's a massive screen, obviously one of the first implementations that happening in the world with 2110. How has been the experience of first making such a large amount of pixels? Because even creating this content should not be an easy task. And then how has been the experience doing these IP video over IP systems?
we have a years long relationship with MSG. We've worked with them at Radio City Music Hall. I think back in 2007 or 2009 is the first time that we worked on projects with them for the Rockettes Christmas Spectacular. That relationship has continued over the years, and then culminating here in Sphere. Um, so they handled the content creation side. A lot of the secret sauce that comes into all the LED mapping, that's all very much proprietary and very much owned by MSG as far as how they're going to produce the content. When it gets to us, that's where we started to apply, our experience in working with these sorts of really high resolution type of displays. Um, when we got to we kind of get into that point of now we're going to start playing this back. There were a couple of things that we knew going into it just from our experience before. We can gen lock multiple machines together, right? So that gives you frame accurate playback. We can,
I guess this is basic.
yeah, just the
It has
basic,
to be
yeah,
absolutely general.
absolutely. So you get the gen lock. Okay, well, how do you apply that in a 2110 context? Okay, well, now we got to do PTP lock, right?
Mhm.
We have to do the content distribution, or if we're going to stream it from the NAS, then we have to make sure that the right stuff ends up in the right place. And that's where we started to add on the asset management to make sure that a server that's assigned to play this section knows to read this part of media from the NAS. So that was a lot of the growth over the last 4 years for us to rise to this challenge of creating something that we don't want to program multiple servers. We want to program one timeline and have all the servers, all the technology get out of our way so that the user can program one show and all of the other parts that are part of that just fall into line and do what they're supposed to do.
Seamless scalability, I guess.
Yeah.
Absolutely. And things like NMOS, what goes where? How do you guys handle this type of challenges?
Yeah. So, cards on the table. Our NMOS story is still in its infancy.
Okay.
So we are adding NMOS to our product range currently. So what we've been doing, when we embarked on this 2110 journey for us, I like to remember this story. A dozen or so of us decided that we were going to, take the training from SMPTE. And we get to the point in the training where we're going to calculate the bandwidth of what we're doing. So we go through the list, and he says, "Okay, we're going to start with the resolution. Okay, we're doing DCI 4K, 4096 by 2060. Okay, cool. And your frame rate 5994. All right, yeah, that's pretty normal. And we're also doing 12-bit. Oh, and RGB. Oh, nobody else is doing that. Are you sure you guys want to do that?" I'm like, "Yeah, sure. Why the heck not?"
Yeah.
So this was 4 years ago when we started that whole process of trying to figure out how we're going to do the very top end of the spec, right? And as we've kind of gone through, we've worked with a number of partners that have been very good to come along the journey with us. NVIDIA has been really strong with us. Fabrics has added support to their signal analyzers so that we can make sure that we're not checking our own homework, but that we're running within spec. And so that's helped a lot of the way. And now we're getting to the point where, okay, we're going away from SDP files, or anybody that's been working with 2110 knows about an SDP. We're moving on from that to add NMOS so that now subscription is a much easier thing. You don't have to remember all the details in SDP. Instead, you can detect all the essences of the network and subscribe to the appropriate thing that you want to subscribe to. We're learning still.
Yes, it is a process because we are all learning, right? These technologies are very new, and they are going really, really fast. And that was another of the questions because that was 2110. Would you have seen any benefits in having something like IPMX in a massive system with differently shaped content?
Yeah, absolutely. This kind of goes back to what I was saying about having EDID-based signal. With DisplayPort or HDMI, if you're going to throw a really funky aspect ratio display at me, that's fine. As long as the processor will receive it, I'm going to send it whatever that resolution is, and that's okay. With 2110 or with SDI, 12G SDI before that, whatever, you didn't really have that option. You were locked into that aspect ratio. With IPMX, we're seeing that kind of bridging of an EDID or display ID type of source and the standards world from SMPTE to give us the ability to, all right, let's take these columns of LEDs that are around us and let's feed something that's exactly that aspect ratio, exactly that resolution. That's going to give us optimization for the signal. We can maybe reduce bandwidth in certain places. Maybe we can push the envelope a little bit more if the
Yeah.
link allows. Then we're not going to say we don't need to saturate 21 gigabits per second for a 4K 12-bit stream. Maybe we're going to dumb it down a little bit, or maybe we just need a little bit more to match that aspect ratio. As long as the display or the processor can receive that, then we're going to be able to optimize that signal flow that much more.
Yeah, absolutely. As long as the bandwidth allows you, and this is one of the main benefits that we see with this type of technologies. So IPMX is going to be this one in which, and I imagine that for the type of things that you guys do, is optimal because you have to render less stuff. You just render exactly what you're going to display, so there is no waste in in spaces. That is what you were showing before, right? You are wasting always something. But in this case, you will be able just to create the exact number of rows and columns that you want to render. That becomes a smaller bandwidth. So optimizing as well networks. That this is obviously for smaller setups, maybe not that important. When you start going to the numbers that you guys sometimes go, it becomes really, really interesting.
Yeah, big opportunities are when you're looking at if you want to build a new museum or something, retrofitting in a current space maybe doesn't really make sense. But if you're looking at a big installation, I I really think that you should give some strong consideration to the 2110 story to figure out a way to optimize your signal distribution, make sure that you have some of the advantages that you get when you have a lot of network based things. If we have a equipment fails. If you have a server that goes down, you tell the other server, stream this piece of content from the NAS and send it to this display over the network. Nobody's in the rack plugging cables, plugging in drives to load content or anything like that. It's a very, very quick process to just say, go grab that content and send it to that display. And it's all based on the network. And it's a big maintenance and stability advantage as well.
Yeah. And as well, I mean, I guess that, for example, we are LED processing, of course, and what we receive is video. But for companies like yours, you have to do something with the audio as well. It has to go to a different place, and things like NMOS allows you to separate these streams and send it to different devices in order to get the project that you're trying to do.
Yeah. Our audio, really, quite honestly, I haven't looked at the audio side of things. So, we are very much video first. We do have support for network audio for AS67 and Dante. And typically we'd rely on, like a Dante controller to help remap the audio. But yeah,
Okay.
we'll make sure that we have that too.
Awesome. Cool. So that was it. Well, thank you very much. Yeah, for me, the most interesting thing is obviously is clearly there is the evolution of technology is bringing these differently shaped LEDs. We are in Vegas. You go out, there is not one LED that is 16 by 9. If anyone sees one LED that is 16 by 9, please let me know. I want to go and see it. Um, there is definitely many different shapes. You have curves, you have columns like fully circular, and we have as well massive LEDs. We have a massive ball in the middle of the city, that,
Yeah.
as you know. And I think that these are the things that are pushing a little bit the future of where things are going for experiences. Uh, what do you think that is going to be coming next?
I I think that if you've heard the story of when the leaders at MSG kind of conceptualized the sphere, it was the way that it's told. It sounds very much like it was a new discovery. It is a new thing. Nobody else has done it before. I think what we're going to see is we're going to see a lot of people that want to capitalize on that initial gamble. I mean, what better place to make it, right? That to have the boldness to say we're going to build a spherical LED surface for 18,000 people and we're going to do it in the desert too. It was quite a gamble. Now I think what we're going to see is a lot of people looking at what the immersiveness that brought in and try to figure out ways that they can maybe extend that a little bit further. Doing, I don't know, maybe movement in the LED might be an interesting thing. You look around at the show
Yep,
already.
there's a
There's a
couple
lot
of
of people
examples.
showing off movement. There's what we've seen here on your display, where you have the frame remapping, right?
Exactly.
You get that sort of thing, but flip that around the other way. Is 3D an option that you might like to look at as far as having running that display at double the frame rate and then giving everybody a pair of glasses to see what's going on, right? I'm kind of curious to see what sort of different ways that people want to take this sort of bold venture and move that into different ways they can adapt it for, other cool sort of creative projects.
That's awesome. Thank you very much, Andy. Great to have you here. I want to mention as well, we have now an integration. 7thSense can control Brompton.
That's yes, yeah. Thanks. So,
Right.
yeah, let's talk a little bit just briefly. So we also have our Medialon show control product range, and we just recently wrote an MXM driver to control the Brompton LED processors. So if anybody out there is using Medialon for their show control purposes and they have Brompton processors, then you can do color adjustments. You can do, all sorts of whatever the API hooks that are available on a Brompton processor can come right into your Medialon web panel.
Absolutely. One of the conversations we were having just now was talking about how these integrations are quite important in order to give a platform in which you can use as a control place for different devices, just to help, first to help the setup and to make sure that people is taking the right decisions, and as well to give a little bit of flexibility and ease of use to these tools. So it is great to have it, and looking forward to do more.
Yeah, looking forward to it.
Thank you very much, Andy.
Thank you, Cesar.
Cheers. Thank you.
Bye.